So it's probably hard to believe that we're already back in school. We're starting back from Christmas break with a review of permutations and combinations. Remember, permutations is where order matters. Combinations is where order does not matter. We have been using the fundamental counting principle, which is a fun way to solve many problems. It involved the introduction of the factorial notation, which you'll see reviewed in lesson 6 here. Permutations, there's a formula on our formula sheet. We have a function button on our calculator for it, so it's kind of nice to work with it. Sometimes there are repeated letters in permutations, and we have to discount those because it's difficult to tell the difference, or impossible to tell the difference between two P's or two E's or three S's. So there's a way of removing those repetitions. And the combination formula is similar to the permutation formula. You'll notice that there's one different arrangement there. I'm going to set up some of the information for the review, give you the answer, and then basically we want to get back into work. So here we go. So again, just trying to get us thinking about review. How many arrangements of the word poppies can I make? Well, without restrictions, I do have to remember that there are 3 P's here. That's going to mess me up a little bit. If each arrangement must begin with a P, that's going to reduce my choice. And remember, I still have repeated letters. If the first 2 letters are a P, well, that reduces my choice further. If all the P's are to be together, that's a grouping arrangement. Remember what we had to do with grouping. All the P's have to be together. If the first letter is a P and the next one is not a P, how am I going to work through that? So my comment here is reduced choice. I'll throw up the numerical answers and then set up the other side, and then we'll see what work needed to be done. So 840 is the answer for A. 360 is the answer for B. 120 is the answer for both C and D. And 240 is the answer for the last one. So just talking through the setup of this committee. For a committee, choice doesn't matter, or arrangement doesn't matter. We just need to pick the people out of the groups, but we have to maintain the description of the committee, 2 girls and 3 boys. So if there are no restrictions on who's on the committee, I get to select 350 different ways. If Johnny, the principal's son, which we assume is a member of the boys in this grouping, has to be on the committee, then our choices go down to 150. Now the Peter and Paul twins, that they can't be both on the committee. That's an interesting restriction. I can view it in one of 2 ways. In either case, the answer sets up to be 300. So I'll give you some time here to see if you can solve for the answer. While you're solving, I'm going to comment on the work that David, Stephen, and Helen did in the next question. So now coming back to just setting up those review ones. So this is 7 factorial over 3 factorial. The next one is 6 factorial over 2 factorial with that first P disappearing. The next one, I have 2 P's that start me off, which only leaves me with 5 different letters to select from. If all the P's are to be together, it's actually the same arrangement or the same number of arrangements. It's still 5 factorial. I've got 5 different items to arrange in order. If the first letter is a P and the next one is not a P, I end up with this as my work. And this one might need a little bit of a description. The first letter must be a P, and then the next letter can be any of the other letters, which is O, I, E, S, and there are 4 of those. And then I must have 2 P's. So I still had 2 P's, but in the second position, I must have an O, an I, an E, or an S. There's 4 different choices for that. And then I have 5 different letters left, which is 5 factorial divided by my 2 P's that are repeated. Let's look at the setup for the other side. So looking at the selection for this committee, if there are no further restrictions, out of the 5 girls, I choose 2 of them. Out of the 7 boys, I choose 3 of them. If Johnny has to be on the committee, that's one of my boys gone. From the 7, we need to assume that. It could be clearer. I still have 5 girls and I have to choose 2 of them. I'm down to a selection of 6 boys and I still must choose 2 of them. If the twins, Peter and Paul, cannot both be on the committee, I can solve it in one of 2 ways. The top way is selecting all of the possibilities, which is like A, 5 choose 2, times 7 choose 3, minus the committee where both Peter and Paul are on the committee plus one other boy. So Peter and Paul have been selected. That means my selection of boys is down to 5. I must choose one other one. And that will be the condition where only one of them will be on the committee. Or I can do it, Peter is picked. So I have 2 more boys to pick, or Paul is picked. I have 2 more boys to pick, but I can't pick the opposite twin. So that's why my selection is down to 5. Or the situation where I have Peter and Paul not being picked. And that gives me 300 as well. Caught my group number not being reduced there. I only have 5 girls to choose from. 5 girls choose 2, but I'm down to only 5 boys because I can't have Peter or Paul, and I must select 3 of them. So that's it for this assignment. I hope that your Christmas break was good. We've got the assignment to do plus a review sheet to try out. Plus some quizzes that are coming this week to practice. Remember, we're testing this week, Friday, on this material. So it's a quick introduction back into hard work. Thank you.